We have a new topic to learn today, objects and classes, and something at the start of that to like motivate it and get you ready for these things. So a lot of cool things to learn. It's kind of like one of the last big pieces of the C++ puzzle that you don't know yet. So that's exciting. So to get there, to get to objects and classes, we have to talk about an intermediate point called structs. Right? Structs are short for the word data structure. It's the struct part, short for structure. So data structure, that's the word that it comes from. And the definition of that phrase is as you would expect it to be. Data structure, there you go. It's like you're structuring data. You're arranging it in a special way, like I have a bunch of ints over here, a bunch of bools over here, a bunch of strings over here. It's like you're arranging your data in a way that helps you solve a problem, right? So structs give us an ability to arrange data in a nice, pretty way, all right? They also give us a way to make our own types. So you said int I, double D, all these things. We can now make our own types with structs. We can make blah s. Maybe that's what blah is, and it has 4 things inside of it, x, y, z, and p. I don't know. Wouldn't that be nice? Or like if you wanted to like program a game, like you want to know like where on the screen are the enemies, like you can have a point type. You can make that yourself. Point p. A struct gives you that ability, so that's worth learning, right? So a struct is a data type that you can make yourself. You get to say exactly what lives within every variable of that type because you're making it. All right, you get to pick all the little mini types inside, and they all get names actually. So like blah s, maybe every blah gets an x, a y, a z, and a p, and you get to choose like what are those things? Are they ints? Are they bools? Are they doubles? They can be different types. Doesn't matter. These variables within your variable are called member variables. All right, they belong to it essentially. That's a new word. And yeah, that's it. A struct lets you make a data structure. It lets you arrange, like this could be an int, this could be a double, this could be a bool, this could be a string. That's what every blah should have, and that will help you solve your problem. Okay? So it's a way of organizing a bunch of data that doesn't have to be all the same type, and each piece inside of your data structure gets its own name. That's another new thing. So it's like variables within a variable, all right? And yeah, every time you make a blah, it gives you one big package of all those things at once. All right, everything you store in a struct is one big thing. It's all together, which is nice, like a double and an int together, in a sense. You get it all at once as well, and so it's in a sense it's very similar to a vector or an array where you can have multiple things in one variable, but now they have names and they can be of different types. Okay, so names are a new thing and multiple types are a new thing. All right, so let me give you a good example. Let's pretend we are making like a 2-dimensional game, and we want to represent like 2-dimensional points on a coordinate system for where like the player is, the enemies are. Question?
For the member variables, can they all be different types on the types, so they don't all have to be the same?
They can all be different types if you wanted them to be. Yep. They don't have to all be the same. Yeah. So that's quite nice. That's a nice thing to have. Nice ability. So yeah, let's make a point struct that represents like every point P can be made up of 2 things, an X and a Y, if it's like a 2D game we're programming. And it's meant to represent the point in space, right, where the X equal to 2 and the Y equal to 3. It's like in one place you can store that coordinate, right? And that's quite nice. And they have names. P has an X and a Y. That's kind of cool. All right, so how do we make this? So let's make a struct that packages together 2-dimensional points, right? Every point variable holds an X and a Y coordinate with those names, and yeah, let's make a struct definition that lets us say point P equals these things. Here's how you do it. Here's how you define this struct point. You say struct, it's a new keyword, and then you give the name of your type, you say point. Usually when you make your own types, it's a capital letter. It's just a common thing. It could have been lowercase point, doesn't really matter. And now I need to move this over because I didn't give myself enough room. And then you give curly braces, and you say exactly what is in this type. What does every point variable get? It should have an X and a Y, and so you just kind of declare those like you would declare any normal variable. It's like every point, this is like the template, the blueprint for every point. It's going to have a double X, because like points can be wherever, right? Doubles are good to have, and then you say double Y. It's like you're declaring it. And now you have a brand new type point that lets you use these things. The one last thing you need to worry about is for very weird quirks of C and C++, you have to put a semicolon after this curly brace, which looks very weird, I know. You can talk to me after class if you want to know why that's there. It's a long story, but somewhat useful sometimes. But you must put that semicolon there. You got to watch out for it. All right. So every point gets these things, and now I have a type. After I say this, I can make it main. I can say point P equals 2.3, point Q equals 3.5, 4.5. Like I get these things. Isn't that cool? That's quite nice. So yeah, I need to show that to you. Definitely. Let me code that first part up right now at least. Okay. So let's go to code real quick, and I'll show you how to use it. I'll call it struct.cpp. All right. So in order to have a point type, I need to create it with the struct declaration, struct definition. And so I'll say struct point, and then in between curly braces with a semicolon at the end, I say all the things that belong to every point. So every point, what should it have? Has an x and y coordinate. So, and they should be doubles, double x, double y. Right? And now that's giving me a brand new type. Instead of saying int p or whatever, I can say point p. Isn't that cool? And then I can use the curly brace notation because it is very similar to an array. It's like, all right, I declare it with an x first, then a y second. So if I give two numbers here, 2, 3, the first thing is the x, the second thing is the y, just because that's the order in which I created the point things. If I did it backwards, the y would have been first. All right, so that's supposed to represent now the point 2, 3. And you can make a bunch of these. You can say point P2 equals 2.5, 3.5, and that's that coordinate, as you would expect. Well, that's kind of nice, right? You can hold them all together. They each get, there's two pieces to every point in x and y, right? So it's a brand new type for us. So, let's see here. What if I do this? Let's say point Q, semicolon, give it nothing. What should happen now? Let's figure this out, all right? So I need to introduce some new terms to you now. So the struct, when I say the struct, that's the name of the type. That's point. Point is the brand new type that I made. It's a struct point, right? Every time you make a variable of that brand new type, it's called an object. So P is called, it's technically a variable P, but we're going to call it the object P now. Object P2, object Q. Any value of a struct type, any variable of a struct type is called an object. That's its fancy term. So when I say point P semicolon, I create a point object as just a local variable. And just like I did with point Q semicolon, by default, everything's garbage, as you would expect. The inner pieces are garbage. The x and the y exist, but they're holding who knows what. All right? And so the x and y pieces inside of your points P and Q or whatever, those are called a couple of different things. Those are called fields. That's one name to say it. So like P, we could say, has two double fields called x and y, or they're called member variables, or just members for short. All right? So I could say instead, P has two member variables called x and y, and they're both doubles. All right, so either of those words work. This is the P object, the Q object. When you make structs, you get objects. All right. So you may wonder how to, like, what if I do make this point P semicolon? Like, how do I set the x and the y separately on a second line? Or if I make point Q like this, how do I set the x and the y separately on a separate line? Because like, it's garbage right now. I have no use for garbage. So here's how you do it. It's the dot operator, which you already know. That lets you go inside of something. You've been using that all this time, all right? So when you say point P semicolon, that'll do this. It's garbage, and you can use the dot operator to set things. So first I should say that every object, right, every point object, P or Q, whatever, they all have their own separate x's and y's. These are the x and y's that belong to P. These are the x and y's that belong to Q. There's also a P2 in the mix in my program. Okay, they're all having separate x's and y's. They're never sharing anything. All right, so P's x is completely separate from Q's x. They're just different parts of a different object. All right, and so if you want a piece of your point, you want a member variable, you want a field, you say its name, the object's name, dot, the name of the field you'd like to either access or change. All right, so I can do this. I can say p.x, please, turn yourself into 42, become 42. That's setting this. It's just like a blueprint. It's a, what's a good way to, it's like the address, essentially. It's like This is like the full address for mailing 42 to this object P, I guess. Okay? So there we go. That will do that. All right, as you'd expect. So kind of read, you've been using the dot operator already, kind of read it as like an apostrophe S. Go into P's X, please, and set 42, not Q's X. Does that make sense? That's kind of how you would do that. And yeah, that syntax works for both setting the value like this and also retrieving it. Like, please print out P's Y member variable. All right? That's pretty cool. And then also, like I showed you, you can just like initialize them all at once with that array-like syntax with these curly braces. Just like give the member variable values all at once in order. That also works. All right? But now you have options. So, let me set Q's X and Q's Y. Q.X equals 4.5. Because right now Q is like question mark, question mark. Let's set the X to 4.5 and like the Y to, I don't know, 7.89. And now we can go and print them. Is there a question first? Yeah.
What if you did like CLQ instead of like CLQ.X?
Right. That's a good question. It's going to be an error. Because it's saying, I don't know how to print a Q. This is a brand new type I'm not familiar with. It doesn't know how. But it knows how to print double, so you can go inside and get the double out and print that. Yeah, that's a great question. So yeah, it has no clue how to print Q right now. There is a way to tell it. I give the whole point to cout, figure out how to print it. You can give some information about how to do that. I'm just not going to show that to you. I think that's a 41 topic. I like to show that in 41. Yeah.
So like, what if you did like CLP since that has like variables in
No, Q is the same. I've set Q's X and Q's Y. They're both points.
Like,
cout has no clue how to print points. Even P is a compiler error. Okay. Yeah, so if I want to print the points, I gotta like go and print the X. Like that's a double. That's cout's fine printing that. Let's print them pretty though. Let's be like, all right, cout, open curly, or not curly brace, but open parentheses, P.X, get that part, comma space, right, P.Y, and then the closing thing, and then like a new line. Like that'll print it and it will be pretty. Look at that. That was nice. You could also write a function, right, called print point that takes a point and prints it. That could work. That would be helpful. Let's do the same for Q. Print Q's X and Q's Y. Look at that. Beautiful. Any other questions about this? So all these pieces you're allowed to access. Right? So, what can we do with this? Technically, structs are a secret brand new way to return multiple things from a function. I told you about using parameters that are references. You could do that, and that will let you set a bunch of things that was somebody else's, right? Or, now, you can return some struct that you made. Like, you can return two doubles and a point, can't you? You can make your own type that has as many things as you need, and you return something of that type. Return an object of that type. Right? So for fun, let's do functions that act on points and like give points back. So let's make an add function on points, and let me pretend like this is what it means to add 2 points. If I add the coordinate 2, 3 to 4, 5, like what is the addition of points? Let's just pretend that it's you add up their x's to make 6 for x, and you add up their y's to make 8 for the y. So that's what let's pretend that's what it means to add points. That's one definition. All right, so let's make an add function on points that gives back a brand new point. Technically returning 2 things, a brand new point with that the summed x and the summed y in it. Okay. So here's how I want to use it. I want to be like add p to q, and that will create a brand new point and give back to me a brand new point. I'll call that like p plus q. Okay, we'll do that. And so now let's go off and we'll make this add function. So what does it got to look like? It's got to be called add. It's got to take 2 points, point A, point B. Technically, we should be taking these by constant reference, but this is enough new information at once. It'll return a brand new point, though. All right, it'll return a brand new point. And yeah, let's figure this out. So if I'm given 2 points, I've got an x and a y for each of them, and I need to make a brand new third point to return. So let's make that to start. Point result. I'll do some fancy stuff to result. I'll fill in the x and the y. and then I'll return result. All right, I can return a point just like I can return an int. Not a big deal. It's a brand new type. So, all right, what does results x need to be? It needs to be a is x plus b is x. See that? Same with y. A's y plus b's y goes into results y. That will give us like the 8 part. All right? And so now result has been filled up with the right things. You could have also just done this syntax probably. I'm returning it. I get something back, and let's see what we get. Let's print it out. Cool. I think it's right? 2 plus 4 from 5 is 6.5. 3 plus 7, 9 is 10.89. It seems to be working. So that's my call with those points. And here is the implementation of it. Any questions why this code gave me a point with those coordinates? It went into the pieces. All right, let's do one more. Let's do a negate point function that just messes with a point that we give it. All right, let's have it work like this. Let's say if we give a, let's say we have a point P in main, we do, that holds an x and a y. All right, so P object holds an x and a y, 2 and 3, let's say. And let's say I want to call negate point on P. Here's how I'll call it. Negate point on P. And the goal of this function is to like take whatever was there, the x's and the y's, and negate them. Like put it in the other, like mirror it across that, like one of those quadrants. I don't know, something like that. So make that 2 negative 2, make the 3 negative 3. That's what I mean. All right. So let's make a function that does that. It will need to take the point by reference, won't it? Because it needs to be able to change it, go into it and change it. So it'll take a point ampersand, a point reference, and change that thing. Void, it'll return void, return nothing, it'll take the point and mess with it. All right. So, well, let's do that. Here's how I want to call it again. I want to say negate point P. And then P should have changed, so if I print out again, I should have like negative 2, negative 3. So let's make this function now, negate point. So it's called negate point. It takes one point, and call it whatever, like A or whatever. It's got to take it by reference because I want to change the values that was passed to me. I don't want to just copy it, and it'll be void. It just messes with that point. All right? It doesn't actually return anything new. So, okay, I've been given a point. I'm calling it A, but it could be anybody else's. Like, it's really P, but I'm calling it A. It's being passed up to here. What do I want to do with A? I want to set its X to be the negative version of whatever it was. Yeah? Same with the Y. Set the Y to be whatever the negative version of the Y was. And that should correctly negate the thing. All right, so there's the thing. There I am negating P. Here I am printing P back out. And I get my negative 2, negative 3 because I passed it by reference. Point reference A, and the interfunction drew that. Point reference A got equal to this, and so it's just another name for mains P. Beautiful. And so it worked on that, and it messed with it. Beautiful. We good with that? I do want to draw a picture of that, though. All right, so let's talk about how in the world is this working. Let's draw a stack diagram, right? This is what negate point is. Its implementation is. How is this like? How's the P getting up into here, and through A we're messing with it. All right, so I think it's useful to draw this diagram. So, oops. What's going on in memory? We have main, right? Main has a bunch of stuff. It has a bunch of local variables. I need a very large stack frame for main. So main has P, and P before, right? Before I call this function, P holds, it was 2, 3. Okay? That's what P holds right now. So it has an X and a Y piece, member variables, right? It has a 2 and a 3. Okay? And then there's also Q. I just won't draw these accurately. There's a P2. Like main has a bunch of local variables. There was also P plus Q. Those are all there, part of main stack frame, we say. They're all main's local variables. And then we call negate point on P. And so, all right, that's new work to be done. We are going to add a new stack frame for that. I'll draw everything that negate point owns in green for the same reason we did that last time. So we're calling negate point. That's a new piece of work to be done, shoved onto our stack. Negate point. And All right, negate point has no memory associated with itself. It has a reference. It has point reference A equals P, because that's what I'm passing, right? So somebody's doing in the interfunction treatment, and point reference A equals P, initializing A to be an alias for mains P, and so negate points A is just another name for that. That's why I needed green, all right? So now through A, I'm messing with mains memory. Does that make sense to us? Is it coming back to us? So that's what's going on. And so I'm up here, I'm working with A. A is X, becomes negated version, -2. That is hard to read. -2. And then Y becomes -Y, right? Through A. And then negate point's done, it returns, like the A goes away, but we're back and still mains memory is still mains memory. Still got P, okay? So that's what's going on the stack. And that's why it's being changed. All right? Does that still make sense? Yeah.
How come you need the ampersand for the reference? Like you don't like change it completely.
I do want to change it completely. This is the only way to change it completely, because do you remember that if I don't do this, I get a copy being made. I get an A for myself up here that's completely different, right? It has its own X and Y, 2 and 3, and I can mess with that, but it does nothing to the memory that I really want to mess with. You remember that?
Yeah.
So yeah, I don't want to copy, so I must use a reference. References keep us from copying things. Yeah. Other questions? All right, so I have a question for you then. So here is my definition of the point struct, so you can see it. Just give you this. So here's how you make a struct, right? I'd like you to do something similar. I'd like you to write your own type, please, in the same vein. I'd like you to write a line segment struct, all right, that represents a line segment in space. So, I don't know, you want to be able to say like line segment LS. And what does a line segment need? Like, what does that mean to be a segment of a line? It needs one way to represent a line segment is to have a starting point and an ending point. Does that make sense? Start. And if you save both of those, then like here is what it means, right? It's representing in memory somehow that. Okay? If you give those exact things. So how would you make a line segment struct so that you could store, like in your LS object, I don't know how big it needs to be, but it's got pieces inside of it, that holds like a starting point and an end point, because that makes a line segment, right? You just connect those two. Does that make sense, the question? So give that a try. For fun, how about we go to the written ice page? You can elect a leader of the group, get with the people sitting next to you, and please try to submit your answer, and we'll see if we got it. All right, there's different ways to do it, though. So try to make a line segment struct that will make you have the ability to represent as many line segments as you like, as many line segment objects as you like. And here's how I want you to represent a line segment. Think of it as like a starting and an ending point, because then you could just draw a line segment between the two. All right? And then please submit your answer. As a group, they'll help each other. And please ask me questions if you have questions. Another minute or so. What would you need? Alright, we seem to be quieting down. Let's see what we're thinking. Nice. Yeah, so if you make a line segment and you want 2 points, a starting point and end point, you can call them like x1, y1, x2, y2. That's perfect. Start x, end x, start y, end y. Cool, cool. I think that's what we all got. Yeah, that totally works. Does that make sense? Because you could store 4 things. That is not a problem. So good job. Please do attendance if you have not done that yet. I will stop that the next time I think about it. So, yeah, you could totally store a line segment as like 4 separate points. x1, y1 for the first point, x2, y2 for the second point. That makes sense, yeah? I think there's a better way. Well, if I have I've gone through the trouble to make a point struct, why not do it this way? Think about what I'm about to do. So I gotta say struct line segment, and then I ran out of room. Boop. Well, you gotta start point and end point. Why can't I do this? Point, start. Point, end. You can do that. That's pretty nice, isn't it? It's like, that makes a little bit more sense in my mind, honestly. So you got a starting piece of your line segment, you got an ending piece for every line segment now, and those things themselves are points. So they have an x and a y coordinate inside of them. They have an x and a y coordinate inside of end as well. You see how you could do that? And how would you set these things? Well, you could do like curly braces within curly braces, that would work. Or you can be like, all right, I want to set, how do you go and you get this y? How do I set just that? Well, if it's called ls, your object is called ls, it's like, all right, ls is start. ls dot start gets me here, yeah. That gives me a point. Let me spell that better. Start. Now I'm here, and now if I just do dot y, I get that y out of there. ls dot start dot y, you can chain the dots. That's really, really powerful, that idea of compartmentalizing these things rather than, again, having to write out all the different pieces separately. I think that's more powerful, and that's a better idea. All right, but 4 variables still works. Totally works. It's not an issue, but might as well use the power of structs. Any questions about that? I like it. So yeah, let me show that to you in code. Boop. So I need to save that. Let's go to, let me steal a lot of this code actually. Line segment.cdp. So I've got a point class, or sorry, a point struct, excuse me. Point struct, I've got an add function that I don't need anymore, and negate point, let's get rid of those. And then let me just get rid of all of these actually. Yeah, I don't need to print anything. So there's my point. Let me do this like this. So you could totally do line segment like this. You could be like struct line segment, like you guys are doing it, double x1, x1, y1, x2, y2. And then to make one, you could say here is let me split screen it, and then in main you'd be like, okay, so I have a line segment now. ls equals, I don't know, 2, 3, and then 4, 5. I'm not sure. Something like that. So that's one way to do it. That would work. But, oh, don't forget your semicolon, like I did. But I think there's a better way. So let's, instead of this, I'll call this line segment 2 so you can see it still. But I'm going to make a line segment struct involving points. Might as well. Let me do that. Struct line segment. Don't forget your semicolon. And then let's do it like this. Let's say point start, point end. It has to be after point because like it doesn't know about points until that's happened. So there's that one. And now I can make line segments like this. I can be like, all right, line segment ls semicolon. I can set each piece of them, right? Because it's got a start and an end, and each start and end are points which hold x's and y's. I can say, all right, ls dot starts x equals 2. ls dot starts y equals 3. ls dot ends x can be 3. I don't know. Ends y can be 4. So I have 2, 3 and 3, 4. Okay, so that would work. You could also use that array-like syntax. If a line segment is made up of 2 points, here's how you can do it. You can be like line segment ls2, I guess. Give it a new name. And you can use curly braces, right? You give it in order, right? You give the first thing, you give a thing for start, and you give a thing for end between curly braces. And then how do you give a point, right? It's also a struct, which takes 2 things. So you could do it like this. You can be like, all right, the x is 2, 3, and the y is 3, 4. Or sorry, the start is 2, 3, and the end is 3, 4. Excuse me. So you see how that's going to fill in all the pieces correctly? You need curly braces per struct, though. So it's a struct within a struct. Cool. You can also set pieces at once using that same syntax. Be like, all right, ls dot start equals 2, 3. That also works. We'll do the same thing. All right? Does that syntax make sense to us? That chaining is a little weird, I think, but it works wonders. It's like separation of concerns. It's beautiful. All right. So yeah, we can look at this example. Ready for more? Because now it's time. Like I taught you structs, so I can teach you classes. All right, that's where we're really trying to go here. That's the cooler thing. It is the backbone of something called object-oriented programming. If you've heard of that, it's a very, very popular programming paradigm these days. Still is. It's been around for a while. Like, if you want to get a job in the industry, you have to know this. This is like going to be the backbone of a lot of things that you would ever do from now on. Okay, so it's useful to understand. It's called classes. It's very similar to structs. All right, everything from structs comes along. All right, so that's why I taught you that first. It was simpler. Classes add more on top of that. Okay, so this is one of the most important topics of the class for sure. All right, so classes package together both data. This is what structs did, right? Just like structs, you put a bunch of data in one place, just like struct. Plus operations. That's the new thing. Classes give you operations on your type as well, and those operations you think of them as being part of the type itself. Part of the type itself. So you kind of define your new type, your brand new type that you're making, because classes make types just like structs do. You're defining your brand new type in terms of like what's inside of it, the data, as well as what you can do to it, the operations. Right? It's a new concept. Right? But you've actually used classes already. You've used objects of a class. You still use that word for classes as well. Like, what are some examples? Because the whole point of this is like object-oriented programming. The idea of it is like to be a metaphor for like the real world inside of the computer. Because like as humans, we think of like, oh, I'm moving this physical object that is the mouse. Like I'm acting upon this tablet. I'm pressing my keys and things, right? We want to make our programs kind of pretend that they're the real world and we can like mess with them and touch them. Like that makes it easier for us to think about as humans. Or so the object-oriented programming people thought. So like, all right, you think about like let's imagine some real life objects that do things. Like let's imagine their operations and like the data that's inside of them. So like a dog, you can say dog D semicolon. what should a dog be allowed to do? Like, what are the operations that a dog can do? Well, it can bark, so it can do like d.woof, and that's an operation. You've seen that syntax before on vectors and strings, haven't you? So, they've been classes all along. Like a cat, my cat, his name is Lonzo. Maybe, like, what's the data that every cat should have? The cat should have, like, a name and an age, among other things, perhaps. And then, like, what operation should a cat have as well? Like, you think about those, you package them into the type as well. Like, all right, you should be able to set the name, of course. Maybe you should have, like, a meow operation on every cat. They should be able to meow, right? They should be able to have a birthday, so that, like, that increments their age member variables. These words are coming back again. Like, eat to grow, I guess. I'm not sure. Something like that. But all those things are possible. And then we take those ideas from the real world, these data and operation ideas, and we try to make programs out of them, like a PowerPoint, for example. Like, here's my PowerPoint. How could we package that together in terms of data and operations? Like, all right, I'll declare PowerPoint for this lecture, and then I'll say, all right, lecture 14, like, what are the operations? Like, maybe I need to be able to add a slide to it on classes. I need to be able to, like, save my PowerPoint, etc. Right? And, like, what's the data involved? Like, it's the slides themselves, maybe. It's like a vector of each slide. I don't know. Does that make sense? It's like packaging together data plus the operations you want to do on the data. Like, you can kind of get this with structs right now. You can just make structs. That gives you a bunch of data, and then you make a bunch of functions on the structs. But this is cleaner. Right? That's what people prefer. So, okay, let's take our point example, and let's convert it to a class. All right, so here, let's think of some operations we'd like to do on points. Right? That's the new idea. It's a new perspective shift. We like to do things on a point. All right, so we want our points to not just hold the data, but also respond to our command. It's like we're sending them little messages, and they respond to our messages. Okay, so like I want to be able to negate a point. So I have a point P. I want to be able to say, not just like call negate point. I want to be able to say, hey P, go negate yourself. Do you see the perspective shift there? Like, that makes more sense as a human. Like, I'm asking it to do something for me. And that's the power that comes from object-oriented programming, right? Addition, like we had a function for that with structs. Let's say it differently now. Let's be like, hey, P, go add yourself. There's always a concept of yourself now, to some other point Q, right? Something like that. Maybe we can scale a point too. Like, what does it mean? Like, hey, P, scale yourself by a factor of 2. And what that means, by the way, like, this is a factor. Like, if you had a point P, like, here's what it means to scale a point. So, like, if x was 1 and y was 2, like, if you ask it to scale by a factor of 2, just like, it means to multiply the values. Multiply x by 2 and y by 2. That's a valid operation. Like, it makes the point bigger, farther away from the origin, right? So, that's the idea. Okay, so those are some operations that I like to have on points. Does that make sense? Don't look at the right. If all that makes sense, now we're ready to look at the right. Okay, so we had struct point. Where did I make that? There. We had struct point, double x, double y. That's all the same. That's all sticking around. The new stuff, the way that you add the operations as well, is you say it like this. Right? You say, instead of struct, you say class point. And then for a reason that I won't have time to get to today, you have to say public colon. Just like, make all these things publicly available for everybody to see. There's a concept of access control that we'll deal with next time. So just remember that for now. And then you give all the things, right? You're still going to declare all the member variables, all the things that need to exist in every point object. Every time you make a point, it needs to get those things. And then you can also start saying operations, all right? So I want every point to know how to negate itself. So that's it takes nothing at that point. It knows about itself. See, it doesn't need to take a point. It has itself implicitly. That's kind of the goal. So it's a void negate operation there. There's a new name for that. I'll tell you later. Then like add. Like, what does add do? It takes some other point and myself. Some other point and myself. It makes a third one. Adds it. Returns that. And then scale. Just call on a line by itself. So it's void. Scale yourself, please, by a factor of 2. So you just take one parameter there. All right. Does that kind of make a little bit of sense? Like, it will make a lot of sense when I give you an example. Actually code this. But that's going to be the start of it all. Okay. This is a more complicated topic today for sure. All right. But it's very, very useful. Very, very important. So, all right. If we're still here and our brains still work, I need to give you more terms, of course. This is like, there's decades of research and people doing this kind of stuff, so I need to tell you all these new terms that have to deal with it. So classes and objects, methods, member variables, member functions, object-oriented programming in general. So okay, a class, like I said, is just like a struct. It's going to make a type. So you say class point, still need that semicolon there, by the way. That makes a brand new type called point. All right, so that's still a thing. It defines a type, and it also gives you operations on that type. Okay, so that's the new thing. And a class, just like I said, a struct is like the name of a type. So like you can make, this is the point class that we're about to make, right? That's the name of the type itself. While an object, you still use the word object for a variable of that class's type, just like a struct's type. Right? So if you say point P, you're making a variable called P of type point. Point is the class, right? It's like the blueprint for the thing. Every point that you could possibly make is made in the image of the point definition. That's the class. And then P is the name of the actual point that you're building right now. It could have been Q, right? And that's the name of your object. Okay? So that's that. Object is a value of some class's type. And you still have fields. You still have your member variables. Those are still synonyms. That's the X and the Y parts. That's still all there. But now we need to give a name for these guys. All right? And their name is called methods. Right? It's called a method or a member function, because like a function that belongs to the class. Okay? Those are your operations. That's what we call them. We call them methods. So negate is, oops, wrong one. Negate is a method. Add is a method on the point class. All right? Scale is a method or a member function. Question?
What exactly is the difference between the fundamental difference between a class and a struct? Besides a class
The addition of these operations. That's the only difference. Well, not in the definition itself. You have to make them separately as functions, and they exist outside of the struct. We're packaging it all together here in a class. Does that make sense?
So it's just kind of how it's structured.
Yeah, I would say so. There's nothing new. Like I told you in like lecture 3 or something, once you learned about strings and loops, like you could make any program under the sun. So you don't need classes to make a program. Just like you don't need, you could use structs and functions all day long. That's fine. But the whole point of this is like to package things together in a nice way that makes sense to humans' brains. That makes your life easier as a programmer. Okay, that's the goal. So yeah, that's a great question. So let's see here. Yeah, so those are the new names, methods and member functions. Those are your operations that we're adding. And object-oriented programming, or OOP for short, is the idea of doing this as much as humanly possible. Right? So making a bunch of classes instead of just a bunch of separate variables. Using those all over the place, calling operations on them, right? Instead of just like a bunch of ints all over the place, strewn about, right? As much as you can. So that's what object-oriented programming is about, like thinking with objects, pretending like these are things in real life that you can ask to do things for you. Okay, so that's the goal. So let's actually code this. Now let's make that point class. Here's how you do it. You're going to say class point. You're going to say public for a weird reason, just like to mark that everything is accessible. I might as well say that. I'll talk about this more next time, but like this public is not necessary for structs. It is necessary for classes. And what it does is like everything is like a section. It sections off the class. It says everything below that you get access to. Like it lets the user have access to it. So it gives the user access to everything below it. And so the idea of sectioning off operations as well, like not giving access, that's a brand new thing as well that classes let you have that you couldn't have before. All right? So that's pretty cool. We'll talk about that next time though. And then like you can just start giving curly braces instead of semicolons, and you can implement the operations. All right? So that's how that works. All right? So you put the methods inside the class just to mark that they are part of it. They're not like, because otherwise, right, the syntax just looks like a function, doesn't it? You need to know like there's a point involved. It's an operation on point. So you put it inside the class. Okay? That's important. And yeah, you can still like make point variables, P and Q, whatever. You can set their member variables just fine. But now you have, once you implement these guys, say that they exist, you can say P.negate. Hey P, go negate yourself. Could have said Q.negate. All right? So let me implement these, and then I'll say more words. All right? So let me steal all this stuff from structs, and we're going to change it around. I should probably call this file classes, you would think. Yeah. Cool. So this is point struct. How do I want to change this? Let's get rid of all of these. We'll make them ourselves. You can still initialize these points in this way. This will still work. I'll keep those. But, yeah, let's pretend we already have classes. How do I want to use these? You can still initialize these in the same way, but like instead of calling a function add, I want to like give a command to an object. I want to say, hey P, go and add yourself to Q and return a new point. That's the new idea. Okay, there's that. Same with negate point. We're not going to have a function anymore. We're going to say, hey P, go and negate yourself. See the difference? That's kind of cool. And then we'll also do like a scale, right? We want to have an example of that. I'll do that later though. But yeah, that's kind of how we would use our class. So okay, here's how you do it. You're going to say, so struct point, you're going to say class point, right? And then you're going to say public, right? You're going to say public, and I guess I'll indent now. You still say what data is involved in every object. What does every point get? It gets these things, a double X and double Y, and now we also have operations, right? We have negate, add, and scale. Maybe I'll steal them from here. It's easier. Boop. So because we're calling them like this, like P, go to negate yourself. Hey P, go add yourself to Q. There's always going to be a concept as we're implementing this of my own stuff, right? Negate on P should be able to touch the X member variable and the Y member variable and negate them, right? For P. So there's always going to be a concept of my own stuff, and I'll show that in a second. So like there are the things. Let's give them bodies. Now let's talk about it. All right. So let's do negate first. That's the easiest. So I'm calling it like this. Oops. I'm calling negate down here like this. P, go and negate yourself. And what's going to happen is we're going to jump up to here and notice that there's nothing there. Like there's no parameters, right? There's no point here or anything. Like I need to be able to touch my X and Y member variables. And the secret is they're implicitly there. When you call p.negate, you jump up to the body here, and if you just say X, you're getting P's X. If you just say Y, you're getting P's Y. You're getting the member variables of the object that you just called that method on. All right? So I'm saying all these new words all at once, I know, but if I say them enough, you'll get used to it. All right, so in here, I can reference X and Y, I can say their names, just because they exist in every point. I get to know, I know that a method has been called on a point object, so every point has an X and a Y. I can talk to it here. I can use it over here. All right, that's the goal. There's always a concept of yourself, right? Your own member variables. X and Y, and they are the X and Y that belong to the object, to the current object that you called negate on right now. That negate has been called on, right? Again, this is just a program to study for sure, but like, all right, I can just talk about X. I can set X to negative X. That's what needs to happen. Because when I call a negate, I'm jumping up here, and if I just say the word X, it's getting the X member variable of that object I got that method called on, right? Same with Y. Right? So that's the correct implementation. Like, even though it looks like X and Y don't exist, they really do, because they're part of every point. Okay? See that? So that's what's happening there. That's why it's going to work. And so with that in mind, let's do the same for the others. So like, all right, somebody's saying point add, right? How are we calling that? We're saying P, go and add yourself to Q. All right? So Q, we're getting into O here. Like, that's just a normal parameter. That's fine. That's an argument to there being shoved here into O. We get to use O, so O.X and O.Y. But we also have our own, right? P is being called on. We're asking P to do this work. So we can still reference X and Y. We can still say the words X and Y, and we're getting P's X and Y in here. Because it was P who we called the method on. Does that make sense? As always, that's the perspective that you need to think about. Okay? So, okay, it's the same as implementation as last time. Like, make a point result. Return that after you set the X and Y. So, but what is results X equal to? It's equal to my own X. So whoever got this method called on it, so P, my own X, plus the other's X, O.X. because that's what we're calling the other thing that I passed, the Q. See that? That's important. We'll take it by constant reference because I just want to take the things and not mess with the things. The same for y. All right. So that's going to be the correct implementation of the add method. Does that still make a little bit of sense? So we're going to, once this gets called, we jump up here, and x and y, they're talking about p's stuff, because it's p who we called this on. It was p dot. Do this thing yourself, p. So this is p's x, this is p's y. We just say it by itself, and then the o, that's what q is being shoved into. Okay? That's that one. And then scale, I should probably call scale before I implement it. Here's how I want to use scale. I'm going to be like, hey, maybe q, go ahead and scale yourself by a factor of 2. So I'll take one double, and then it will have been made bigger, scaled by a factor. That's how I want to use it. And with that in mind, let's implement it. So, all right, now it's q that we're asking to do something, right? Q, go and scale yourself. So when I jump here to this body, what's going on is I can say x and y, and I'm getting q's x and q's y. Does that make sense? It's just whoever got this thing called on it. And all right, I want to mess with q's x and make it scaled by a factor of c, whatever c was, for x and y. All right, so that's going to be the correct implementation for scale. You can just say x and y because every point we know has an x and y. Okay, I know this is weird, and this is new, but that's going to do it. All right, so let me go back to one window. Let's go back down here where we actually saw things happening. So all right, let's see if it still works. So we had P, go add yourself to Q. 6.5, 10.89. Cool. P, go negate yourself. All right, now it's -2, -3. Cool. Q, scale yourself by a factor of 2. That's Q right here. So 4.5 times 2 is 9. 7.89 times 2 I will assume is this. Cool. And it's working. So every time we call it, like we call P.negate, it jumps up here. You talk about X, you talk about Y, you're getting P's X, P's Y. If you said Q.negate, you'd be getting Q's X and Q's Y. It's just whoever you got called on. Okay? Any questions about that? I will draw a diagram in just a second to help a little bit, but like that's the meat of it all. So there are operations, and we're implementing the operations. There's always a concept of who we got called on. P, go and negate yourself. And you jump up here, and now it's P stuff that you're messing with. Right? It's always the current object stuff. So yeah. Let me draw a diagram, a little stack diagram of what's going on when you call P.negate. All right, I think that will be pretty helpful. What else? So yeah, like I was saying, this is what happened, and then I'll draw a stack diagram too. So we had a P and we had a Q. So let's see here. If I do that, let me kind of draw what's about to happen. So point P, comma Q. If I say P.x is 1, P.y is 2, that'll set those, and then the x and y of Q, for this example on the slide, Q is still undefined. It's like question mark, yeah? And then you can say, hey, P, go negate yourself, and so it jumps into the body of negate with, like, the x and y talking about P's x and P's y. It's specific to just that, all right? And it's telling it to, all right, go and make the x negated to whatever it was, and the y the negative version, okay? So it's talking about P's stuff. If you said Q.negate, it would have gone and messed with Q's member variables. It would have jumped to the body, and X and Y would have talked about Q's things. Okay? That's what's happening there. Boop. There we go. And so, okay, inside of P.negate, let's talk about it. So you say X, it's P's X. You say Y, it's P's Y. It just knows those things. All right? So let me draw a stack diagram. So we were in main. Main got called. So main got called. And so what what local variables did main have? It had P, P2, Q, P plus Q, those all existed. And P was 2, 3, wasn't it? Yeah. 2, 3. And then Q had an X and a Y. You had like P plus Q, all those things existed. I won't draw them in, really though. They're unnecessary right now. Any other things, I guess. One other thing. So, okay. I have this, and I'm going to say P, go and negate yourself. Let's talk about this one, P dot negate, okay? So what happens is we call negate, it's a method on P. So there's always a concept of who you got called on, who that method got called on. It was P that we called negate on. So we're going to jump up here to the body of the negate method, all right? It's still like a function call, though. It's still going to make a stack frame. A method is just a special kind of function, essentially. So we're in the implementation for the negate method now. I'll say that everything that belongs to the negate method is in green, because it's very similar to references right now. So once you jump up here to the body, X is being set to, like, you say X, you're really getting P's X. Does that make sense? Like, you say X, you're getting P's X. The green things you can see inside of negate. You say Y, you're getting P's Y, because that was who you got called on. That's the magic. That lets the magic happen, okay? So it's always, and then, okay, now if you just mess with X and you mess with Y, like here, those are all visible right now, that's messing with P's X and P's Y. So that becomes -2, that becomes -3, and it's doing all the things you expect, right? So inside of negate, just like the things that are alive, things that you get to see by default, are the member variables of that object that you just got that method called on, okay? Any questions about that? It might just be something you need to study this example code. It is a lot of new information, I know. But this will make sense if it doesn't fully make sense yet. All right? But what I'm trying to say is, this is important, when you call a method, it's like, who did you call it on? Was it P, was it Q? Because that depends on who you're touching. Like, what member variables are you messing with? Like, what is alive when you get to the body there? All right? So it's always the current objects, right? There's a concept of your current object that the method is being called on. So it's P, go and negate yourself. Go mess with your own member variables, right? So it's P's member variables that are visible inside of the method in this case. So you're getting P's X when you call a method on P, like when you say P.negate, and you just ask about X, all right? You would have gotten Q's X or Q's Y if you said Q.negate, okay? Does that make sense? It's just being done for you by C++, and we are very thankful for it. Okay? So, if we are happy enough, I'd like you to try, all right? Just like I did last time, I think it's useful to just play around for a little while. I'll give you plenty of minutes to do it. We got some time. So let me give you all of this code. Legitimately all of it. So if you would like to go onto Canvas and go to the, just like in the second module, the code from class page, I will give you all of this code in the lecture 14 folder. So just go to code from class, go to CSCI 40, and right now you should have in the lecture 14 folder classes.cpp. That was the file that we were working on. Oops. So here's this file. You have it now. You can copy and paste it into the server, or just like on a website where you can edit C++ if you'd like. But here's my task for you. I'd like you to make your own method inside of the point class. See if you can make your own, all right? Here are some options for you. Let's say an easy one would be something like p.print. That's very helpful, right? Because I was like, there's a whole lot of code just to print a point out, like all these cout things, like put that in a method, make it easy. Just, hey, P, go print yourself. That's kind of nice, right? Do that maybe. Another option is like, hey, point object, go and reflect yourself across the y equals x line. You know what reflection is, right? So like, if you have this point to reflect it, you just swap the x and the y values, and now it becomes this point. That's one way to reflect it across that y equals x line. That could be another one. That could be useful. You could also do one that returns something. Be like, hey, point P, go and calculate and return back your distance to the origin, distance to 0, 0. If you know the formula for that. So it would have to return a double, right? You have to do the square root and all that. You can see out that. So those are some options, but I'll give you like 5 minutes to play around and ask questions if you're running into issues. But like, you have the code now in the lecture 14 folder. Try to make something. I think that would be really helpful. The easiest one would probably be print, because I already gave you like what printing should do. It could look like that pretty thing that I didn't make. Okay? So yeah, take a little while to try that. And please yell at me if you have any questions. It's in classes.cpp. It's in lecture 14's classes.cpp. Do you see it? You just copy and paste all of that and follow my lead. You want to make an appointment, for example, go to the appointment. So maybe you can copy the meet. Tell me if any issues come up. I'll try to help. But the best way to learn is to try it yourself. Oh, that's true. It's just going to print something. It doesn't need to return. Kind of like an gate. Point two. I'll print it. Take nothing. It'll be a point. I assume it's there. We'll have to work on that tomorrow. Another minute or so to play around, and then I'll bring us back, and I can let you. You can play more after that, but I just want to bring us back and conclude. Alright. That was my timer, at least. So feel free to keep playing. I just wanted to bring us back together and ask, like, are there any questions that came up as we were trying that? Did it all make enough sense? Did we get it to do what we wanted it to do? Or were we too shy? Alright. If you're happy, I think that is where I want to stop with the lecture. We'll talk about more next time. Let's stop then. And as far as new things go, I need to give you some stuff, but I guess we'll just wait until next time. So the rest of the time is all yours to do whatever kind of work you want to do.